In this video, I will be explaining what a lower end bearing failure is. Finding the root cause of the failure is very important. It is necessary before deciding the responsibility for the failure. It is essential to know that this process is not an easy one. It can be time consuming. It's more like an investigation than a diagnosis. Hey guys, I'm Adam with TAT Express, and I'm a veteran airman with over a decade in the truck and repair industry. On this channel, we cover truck repair, maintenance, and we also share knowledge about the trucking industry. Be sure to subscribe and turn on notifications. Also, be sure to like and share the videos so that we can share the knowledge. If you are traveling through the lower states, we are located in Dallas, Texas, just off of Interstate 20 and 45. Call to schedule an appointment at 972-225-3017. Guys, if you'd like to share your experience, leave it in the comments below. Let's get right into this video. When determining the root cause or primary fail part, there are many factors that we need to examine. Usually, when a lower end failure occurs, the truck will arrive to the shop with a rod out of the block, a seized up or locked up engine, a no crank, no start, a noisy knocking, a cylinder misfire, or even engine vibration. Since there are many lower end bearing failures, it is essential to understand the lubricating system designed for the DD15. First, I want to explain how the oil flows through the engine. First, oil passes through the oil suction manifold. Now, this oil suction manifold houses a check valve that keeps the oil system primed when the engine is off. It's important to know that if that oil suction manifold is removed, that the oil system must be primed before starting the engine. That's very important to know. The oil suction manifold is bolted directly to the block and it's connected to the oil pump via these oil lines. Now, this has been an area of concern with the DD15 because since this is what supplies the entire engine with oil, over time, the O-rings that seal the manifold to the pump become hard and brittle, losing their sealing power and causing low oil pressure faults during idle. If you are experiencing low oil pressure faults during idle, it is vital to get your unit serviced before damage can occur. It's very important. The oil pump is also bolted directly to the block and it is gear driven. It has internal impellers to create the oil pressure needed for the engine. The oil pump also houses a pressure regulator and a pressure relief valve. The pressurized oil is then sent back to the oil suction manifold and fed through the block up to the oil cooler and oil filter. Once the oil is cooled and filtered, it supplies pressurized oil to the main galleries located on each side of the engine blocks. The main oil galleries supply oil throughout the engine. The gear train, rocker arm assembly, turbo, main, and rod bearings are supplied with pressurized oil from the main oil galleries. The oil suction manifold is designed to keep the oil system primed while the engine is off, which will help to prevent starvation during startup. It is essential to prime the oil system if the oil suction manifold is ever removed. Now that we understand how the lower bearings are lubricated, we want to find out as much information about the failure event, finding out where the failure occurred, if there were any abnormal issues noticed prior to the failure, prior maintenance history, and if recent repairs are items you need to pay attention to. We are looking for any information that can be helpful. The next item we want to inspect is the ECM readout. Inactive and active codes will allow us to see if the engine was ever running in a condition that would cause a lower end failure. A DDAT report is also a good source of information. Be sure to evaluate any codes. This includes inactive and active codes. Codes of interest for a lower bearing failure are overspeed. If engine exceeds 2,500 RPMs while the vehicle is moving, is considered an operator-induced engine overspeed. Oil pressure or oil temperature codes. There are many possibilities for these codes, so keep an eye out for these codes there. Coolant level. If there is any head gasket failure or liner failure, the oil can be contaminated with coolant. Injector codes. These codes include pressure-related codes. Fuel can enter the oil system and cause oil dilution. As mentioned before, repair history is something you want to pay close attention to. For example, debris can be introduced into the engine's lubricating system when conducting an injector replacement, cam housing repair, oil pan gasket, or a turbocharger. If any of these components have been recently replaced, it indicates a need to look further into the repairs to ensure they have not led to a lower end bearing failure. DD15 main bearings and rod bearings are designed to withstand high load capacity, and they achieve this by using a lead-free tri-metal bearing with a hard top layer. Now, the downfall to this design is that it's less forgiving to debris and lack of lubrication. This is why it is essential to make clean repairs to the engine so debris is avoided. It is essential to follow the proper steps for a repair. Inspection of the oil filter is another item to pay close attention to. The oil filter has a standpipe design that allows unfiltered oil to enter the clean oil side during a cold start if there's not oil readily available. We want to inspect this standpipe because if the bypass valve is stuck open, this will cause an excessive amount of unfiltered oil to enter the mains and will increase the chances of a failure. Ensuring the correct oil filter is being used and inspecting the oil filter for signs of metal, coolant, or recently replaced oil filter are items to check for. Inspection of the oil is the next step we want to take. Drain a quart of the oil into a clean container and let it sit. Wait for about 30 minutes, and what we'll be looking for is separation of fluids such as fuel or coolant. The origin of the leak must be found if contaminations are found. Clean, fresh oil is an indication of a recent oil change. Next, we're going to drop the oil pan and check for foreign materials. Due to the lower end bearing failure, you're going to be finding a lot of metal down there. But we'll be looking for items that do not relate to the actual failure, such as bolts, screws, broken gear teeth, or turbocharger bearings. When removing the oil pan, you want to inspect for recent repairs. If there is fresh silicone or a clean pan, this would be an indication of a repair. Also, rounded head bolts are an indication of a recent repair. The next item we'll be inspecting is the oil pump and oil suction manifold. The oil pump is the heart of the system. We'll be looking for cracks in the housing, loose mounting bolts, damage to the drive gear, or loose regulator or relief valves. Inspect the oil transfer tubes for cracks or damage. There will be a history of low oil pressure codes if the O-rings have failed, causing oil starvation to the bearings. Failed transfer tube O-rings will damage only the rod bearings, not the main bearings. Next, we'll inspect the oil suction manifold. We'll be looking for cracks, inlet screen damage, or missing plastic pieces. A missing plastic cap will cause immediate loss of oil pressure. There are 4 different types of bearing failures, and understanding the different types will help you in finding the root cause of the failure. The 4 different types of failures are due to debris, contaminated oil, oil starvation or lack of oil, and assembly quality. The most common type of lower end bearing failure is caused by the debris. Now, this is the same for all platforms. Debris is shown by the bearings with lines of light scratches or deep grooves. This is noticed by scoring that is deep enough to show copper. As I mentioned before, the high load main bearings have a very hard top layer, so the debris is less likely to get stuck or embedded in the bearings. Debris will score up the bearings and get stuck in the oil clearances between the bearings and the crank journals. Oil clearances are very tight, so any debris caught in the area will cause a spun bearing. This damage can be shown across all mains or on a single journal. Lower end bearing failure caused by contaminated oil can be seen by missing sections of the top layer to smearing of the complete bearing surface. There should also be evidence of coolant loss or fuel contamination prior to the bearing inspection. You will see this light oil starvation on the engine with low oil pressure due to failed O-rings. When major oil starvation occurs, bearings will have a white surface. Since there is no oil, the metals become in direct contact with each other. A lower end bearing failure that was a result of poor assembly will usually occur within a short time frame of the repair. When this type of failure occurs, it will be isolated on a single bearing journal or piston. When you have an isolated failure or a single component, that is considered a vertical failure. A systematic failure is when you have more than one same component damaged. This is considered a horizontal failure. If you have an isolated failure, this can rule out the failure was caused by a systematic failure such as oil contamination. This is another reason it is important you have an experienced shop conduct repairs on your DD15. Improper workmanship during a repair can cause a lower end bearing failure. Now that we understand more about this type of failure, let us use this lower end bearing failure as an example. The truck was towed into the shop with a seized engine. There were no related codes or signs of coolant leak or fuel leak. We found damage across all mains and rod bearings. Customer stated that the failure occurred right after an oil pan gasket repair. We inspected the oil filter standpipe for damage and found a broken bypass valve, which feeds unfiltered oil directly to the main. Debris, clogged oil clearances causing spun bearings. This failure would be caused by debris due to poor workmanship. Great care must be taken to ensure debris do not enter the engine during repairs. If you would like to schedule an appointment, call 972-225-3017 or email info@tatexpressinc.com. We are located in South Dallas, just off of Interstate 20. Thanks for watching the video. Be sure to like, share, and if you're not subscribed, be sure to hit that subscribe button. Until next time, guys, be safe.